Move into lesson 5.4. You'll notice it's called multiple angle identities, and you'll notice that there are more identities here listed, yes? So to answer the first question, yes, these identities will be added to the page of identities that I will be giving you to use on the test. Okay, so at no point is it about memorizing the identities in this chapter. It's about being familiar and understanding how to use them. Okay, these are all multiple angle identities because it's not talking about just sine of theta or cosine of theta. Okay, we have three different types. We have the double angle identities here. So double angle identities are when it's sine of 2u, cosine of 2u, or tangent of 2u. So when there is a 2 in that with the variable. So 2 times whatever the variable is. So those are our double angle identities. You'll notice sine of 2u is 2 times sine u cosine u. Notice cosine 2u. We have not one, but we have three options. They're interchangeable. It depends on the situation, the problem, as to which you want to pick to use. Okay, so, and there might be a situation where you pick one to use and a neighbor picks another to use, and you can both reach the same answer. No, you don't have to use them all. It's usually pick one out of the three. Okay, and then there's a tangent of 2u. Okay, so these are identities to use when it's no longer just a variable, it's 2 times a variable. Okay, we also have power reducing identities. These power reducing identities, notice it's for the squareds. So when you have sine squared, cosine squared, tangent squared. And the idea is if you're trying to get rid of a squared. So if you're trying to get it so it no longer has sine squared, it just has a regular trig function. Okay. And then we also have half angle identities. So half angle identities help us out when the variable is divided by 2. So sine of u over 2, cosine of u over 2, and tangent of u over 2. Okay, so not a whole lot I need to say about them other than we just need to practice with them, look at some types of examples with them. You'll have a couple of different types of examples in homework. And what I was trying to remember is if everything in homework directly correlates or if some of it is a little extension from homework. So let's look at example 1. And example 1 says, if sine of theta is 4/5. So telling me sine, and they're telling me cosine of theta is less than 0. Find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. We'll take a guess. Which identities are we using here? Yeah, double angle identities. They gave us a sine of theta. And they're asking us to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Now, as you look at, do I still have them on the screen? Yes. As you look at each of these, notice they give me sine, yes? Is sine all I need to know? No. By the time I get done, so essentially we're doing 3 problems in one here. But by the time I get done, I'm going to need to know regular sine, cosine, and tangent. And so my suggestion is that we start off with that. Thoughts? If they tell me sine is 4/5, sine of theta is 4/5, and cosine of theta is less than 0. Thoughts on where I can begin to just finding what cosine of theta and tangent of theta are? Draw a triangle? What were you going to say, Levi?
I was going to say we know that cosine's going to have to be negative.
Cosine's going to have to be negative, agreed. So if we draw a triangle and taking into mind that cosine has to be negative, so a couple of details here. Cosine less than 0, I agree, is negative. Sine is obviously positive, right? What quadrant does that put this triangle in that I'm getting ready to draw?
2. For the first and second. Well, so now in the first. Oh, well, cosine is negative. Yeah, I got you. So then, yes.
I'm just letting you guys talk it out for a moment. That's, you guys have to talk it out, but you guys, okay, so all students take calculus is how we're figuring this out, yes? And the fact that sine is positive, puts it in one of the top two, right? But cosine is negative puts it over here in quadrant 2. Okay? So as I draw this triangle, I'm going to draw it in quadrant 2. So the idea when I draw this triangle is it looks something like this. Remember when we draw these triangles, the angle is always on the x-axis. So where is my theta? It's on the x-axis and at the origin. So that angle right there is my reference angle that we're talking about, right? My right angle is obviously over here. Can you label these sides? And by the way, in case you didn't figure out, I did draw this in quadrant 2. What do you know about the sides? Opposite is 4, hypotenuse is 5. Are we ringing some bells here? I'm taking you back, exactly. I'm taking you back to the beginning of chapter 4, which does seem like forever ago. So the phrase you should be thinking, if you're not quite with me. SOHCAHTOA sound familiar? Right? So SOHCAHTOA, so they gave me sine, so they're telling me opposite is 4, hypotenuse is 5. So in response to this angle right here, right? Opposite is 4, so that means the height of the triangle is 4. The hypotenuse is 5, which, that diagonal side, right? Okay. Can we find the third side?
Yeah.
Thanks to Pythagoras, we can. In other words, Pythagorean theorem. I wasn't going to necessarily write this down because I'm conserving space here. But what is that third side going to be? 3? Yes. Because x squared plus 4 squared equals 5 squared. So then x squared plus 16 equals 25. 25 minus 16 is 9. And the square root of 9 is 3. Now, what do you know about that 3 because we are in quadrant 2? It's negative. Because which way is that 3 going? To the left. If you go left, it's negative. If we were going down, it'd be negative. The hypotenuse is always positive. Ring a few bells? Are we comfortable with the triangle there? Good old geometry. Okay, so we were already told, and I'm just writing it down so I have it, that sine of theta is 4/5. Get that written down, and then I want to know, can you tell me cosine of theta? What do you got? Negative 3/5. Cosine is adjacent over hypotenuse, and notice my adjacent was negative because we're in quadrant 2, so negative 3/5. And can you tell me tangent? Negative 4/3. Tangent is opposite over adjacent, so that's 4 over negative 3. So some variation of negative 4/3. Quick self-check. Do all of my positive negative signs make sense, knowing that this angle was in quadrant 2? All students, so sine is positive, everybody else is negative. Is that what worked out to be true? Okay. So that's the information we need going into this problem. Okay? So now we're ready to actually start the problem. That was kind of all the pre-work. How am I going to find sine of 2 theta? We're going to use What from up above?
Double angle identity.
Yeah, the double angle identity. It defines, up there it uses U. Obviously in this problem we can change our U's to thetas. You guys are probably going to change it to thetas or x's because those are the only two things you appear comfortable with. But okay, so sine of 2 theta according to up above is 2 sine theta cosine theta. Can you fill in the information? Well, it's multiplying 2 times whatever sine theta is times whatever cosine. Yeah, it's just multiplying the pieces once we get them filled in. So 2 is 2. What was sine theta? 4/5 times cosine theta, that was -3/5. If you want, 2 as a fraction is 2/1. Do some math. It's mental math, my opinion. What's this multiply out to be? Multiply across, guys. Two times 4 is 8, times -3 is -24. 1 times 5 times 5, 25. You guys got to help me out here. So, what is sine of 2 theta? -24/25. That wasn't horrible, was it? Okay. Unfortunately, that was only one of our 3 answers. Yep. Okay, so in order to find cosine of 2 theta, look up above, and there are 3 options. Technically, you grab whichever one looks most interesting to you, or in other words, whichever one looks easiest to you. I really don't have one that looks, in this case, it'd be different if we were only provided cosine or only provided sine, right? You'd want to go to one of those rather than find one unnecessarily. But we already had to know sine and cosine for the previous part of the problem. So it really doesn't matter which you use. Pick one and use it. I personally was going to use cosine squared theta minus sine squared theta and try and leave room. Remember, we still have to do tangent at the right. Why did I just underline that? I think I got to thinking about fraction or tangent and thinking, oh, it's going to be a fraction, and goodness.
Emphasize it, that's the whole.
I guess. I don't know. Okay. First step's easy, right? Fill them in. Now, it says cosine squared. So what's that mean we're going to do? Yeah, -3/5, and we're going to square that. Minus sine squared. So that means we're going to do 4/5 squared. Do the math. What's -3/5 squared? Okay, negative times negative is going to make it positive. Square both numbers, 9/25. Minus, what's 4/5 squared? 16/25. What's 9/25 minus 16/25? -7/25. And that is cosine 2 theta. And tangent 2 theta. Oh, and by the way, on cosine, if anyone tried one of the others, you should have gotten the same answer. Or if you want to go back and try one of the others at some point, you get the same answer if you do the correct math. Okay, tangent of 2 theta. We're back to having one option, correct? So tangent, we're going to be using 2 tangent theta over 1 minus tangent squared theta. I can. You're welcome. Fill in the pieces to begin with, right? 2 tangent theta, so 2 times negative 4/3 over 1 minus tangent squared, so negative 4/3 squared. Okay, on top, 2 times negative 4/3. Negative 8/3, because 2 as a fraction is 2 over 1. So you multiply 2 over 1 times negative 4 over 3, and this is negative 8/3 divided by 1 minus, what's negative 4/3 squared? Okay, so negative 4/3 squared is 16/9. So then we're going to do 1 minus 16/9. So what is 1 in terms of ninths? 9/9. So we're doing 9/9 minus 16/9, which is negative 7/9. Was 4/3? Did you guys follow that all right?
Yeah. So how come that doesn't negative don't turn out to a positive?
You have to square it before you subtract.
Oh, okay. That's what cancels that, and then it goes back again.
Okay. So 1 minus negative 4/3 squared. 1 minus negative 4/3 squared, so negative times negative is positive. 4/3 squared is 16 over 9. We got that far.
Yeah.
Okay? In order to subtract 1 minus 16/9, common denominator. We need a common denominator of 9.
So this is 9 over 9 to make it equal 1.
9 over 9 minus 16 over 9, which is negative 7/9. Better?
Yeah, that makes sense.
Write that down on the side of your paper, the back of your paper, something if you need to, or right above it or whatever. Okay. How do I finish this off?
By multiplying it, you have to do the reciprocal.
Yeah. In order to divide 2 fractions, we multiply by the reciprocal. Or in other words, you keep the first fraction, which the first fraction in this case is the top fraction. Change division to multiplication, and you take the reciprocal of the second fraction, which means you flip it, and so it's negative 9/7. Yes, my dear? Okay, did I move it just enough? Okay. Did you guys get your keep, change, flip? Multiply by the reciprocal. So negative 8/3 times negative 9/7. I don't know that a lot of you would, but I personally would cross cancel here because I don't want to have to reduce that fraction that's going to need reduced. I mean, you can go ahead and say, what, 72 over 21, but then you have to reduce. I don't know if I would catch that reducing as easily. Maybe I would. What do you know about 3 and 9? Yeah, they can divide both by 3 and become 1 and 3. So then, 8 times 3, 24 over 7. And it was a negative times a negative, which makes it positive 24/7. Basic fraction skills mixed in. Gotta love it. Oh, there you go. Good day to do that then. Okay. Okay, we need, for example, 1. And we'll move to example 2. Okay, example 2, you ready? Rewrite cosine to the 4th x in terms of trigonometric functions with no power greater than 1. Not what they're intending. I see your point, but his comment was cosine to the 4th. Well, if I'm writing it with no power greater than 1, cosine times cosine times cosine times cosine. Point made, however, not the design of, not what we are wanting. So, and I guess technically how I could argue that is, well, but if you simplify that and multiply it back together, you're back at cosine to the 4th. So, okay. If we're trying to write cosine to the 4th, no power greater than 1, what type of identity am I going to use? Power reducing, because what are we trying to do? We're trying to take a 4th power and reduce it. Logic? Okay. Now, the problem they give us is cosine to the 4th. What do you notice about your power reducing identity up above? It's cosine squared. The only power reducing identity we have are for squares. So what do you know about cosine to the 4th in relation to cosine squared? Yeah, you can either think cosine squared squared or cosine squared times cosine squared, yes? Okay. Let's see. They have equal work, whether we say cosine squared squared or cosine squared times cosine squared. But I think you guys are going to see it better and what has to be done if I write cosine squared times cosine squared. Does that make sense? Okay, so cosine to the 4th x. Again, I can write it as cosine squared x raised to the power of 2. And that's technically what I should do. But I think the better visual to continue the problem is if I write cosine squared x times cosine squared x. And I think that's more what more of you said than the other anyways. Okay. So, cosine squared x. Do we have an identity for that? According to our identities up above, what is cosine squared? Yeah. We'll put it in terms of x since that's what they provided us. So according to the power reducing identity, 1 plus cosine 2x divided by 2 times another 1 plus cosine 2x divided by 2. All this problem asks us to do. Okay, so the question was, now I'm seeing the double, needing to use a double angle identity. However, all this problem asked us to do was to go from cosine to the 4th and make it so there's no power greater than 1. Did it say we couldn't have a cosine 2x in there? This cosine 2x is cosine to the 1st with a 2x in there. So we're allowed to have a 2x in there. We just can't have a power in there. Okay? Okay, mathematically, what do I have to do next? Multiply the fractions. How do we multiply these fractions? We have to FOIL. Which is why if I had just written it out as a fraction squared, some of you would have missed the whole FOIL concept. So yes, this is a FOIL. Okay, and so I'm going to make it one big fraction, if you will. 1 times 1. Get the easy stuff while you can, guys. 1 plus. Okay, outsides. 1 times cosine 2x is 1 cosine 2x or cosine 2x. Now, can you do the insides with me at the same time? The inside is cosine 2x times 1, which is another cosine 2x. So what's 1 cosine 2x plus 1 cosine 2x? 2 cosine 2x. And now last, cosine 2x times cosine 2x. Almost. Cosine squared, but the 2x is the variable that's in there, and that's what allows us to be able to multiply it together is because they're both 2x's. So it just stays 2x. So it's cosine squared 2x.
So it's not cosine 4, right?
It is not. The only thing, okay, so if this was, say, cosine 2x times cosine 3x, we wouldn't be able to multiply them because they don't have the same variable parts. So because they're both 2x, that's what allows us to multiply them. When you're multiplying cosine times cosine, the cosine is what you're multiplying. And so that makes it cosine squared. The variable just stays the same, whatever you do. Okay? Don't forget your denominator. 4. Get the easy part, right? 2 times 2 is 4. Okay. Examine this problem for a moment. Our overall job on this problem is to rewrite cosine to the 4th x in terms of trig functions with no power greater than 1. Because after we FOILed that, we now have a power greater than 1 back. Well, what's going to come down to, because we have a power greater than 1 right here, we're going to have to redo that term. Okay, so because there's a cosine squared, we have to, how do I want to say this? We have to use the power reducing identity on just that term. So we're using it a second time. And this is all because it was cosine to the 4th. Okay, they're making us work at it. Now, I'm going to bring my math up here. And let's see, is this where yeah. Because I really don't want to put a fraction in there within a fraction, because that just sounds even worse than it already is, right? Okay, so as we go, 1 4 in the denominator, that 4 in the denominator goes with everything on top, yes? So I'm going to break this up into 3 terms being added. The first one is 1 over 4. And again, I'm doing this because I don't want to have a fraction within a fraction at the end. Okay? When I get to that final term. Plus, the next one, 2 cosine 2x over 4. Thoughts? If it's 2 cosine 2x over 4, divide the front, the coefficient, by 2. The cosine 2x stays as is. So what do you know about 2 over 4? out front? It's 1/2. So I'm going to write this as 1/2 cosine 2x. Plus. Now, on this next term, it's just cosine squared 2x. And I'm actually going to sub in the identity here in a moment. But what about this 4? What's it going to be written as out front? 1/4, because there's really a 1 out here, yes? So I'm going to say 1/4. And then, notice I didn't write the cosine squared 2x because I'm going to rewrite it with the identity. Okay, so this right here, I'm going to rewrite with an identity. Cosine squared, now notice it's cosine squared 2x. That's going to create a little different piece to this one because last time it was cosine squared x. So x is like a u, yes? This time, what's this supposed to be? This is supposed to be a u, isn't it? Yeah. Okay, so that 2x, we're going to have to pay careful attention to that. Yep. Whatever our variable piece is, we're going to multiply by 2. So, write it out with me. The 1/4 was already there. Cosine squared of something. Well, cosine squared of something is written as the fraction 1 plus cosine of 2u. Except what is in place of u? 2x. So it's 4x. Because it would be 2 times u. But we have a 2x there. And 2 times 2x is 4x. And it's all over 2. Okay? Now, from here, it's all about cleanup. Okay? So I'm going to keep the initial part the same for right now. It's still 1/4. It's still 1/2 cosine 2x plus, and it's still 1/4 times this fraction. Well, I'm going to. Okay. I mean, the key is at this point, even once we multiply that 1/4 in there, we're not going to get anything bigger than power of 1. So we're safe in terms of power. So that's why it says just clean up. But, okay, can you split this into 2 fractions with me? If I keep that 1/4 out front, kind of like we did earlier, this 2 in the denominator goes with what? Everything, each term in the numerator, right? So 1/2 is 1/2 plus cosine 4x over 2. But how have I been writing the denominator of 2? Out front as a 1/2. And it's technically algebra we're doing at this exact moment. It's algebra with trig mixed in, but it's still technically our algebra skills. Okay. What about that 1/4 out in front of my parentheses? Distribute. Okay, so rewriting the beginning piece again. 1/4 plus 1/2 cosine 2x plus 1/4 times 1/2. 1/8 plus 1/4 times 1/2 cosine 4x.
Would be cosine 2x.
1/8 cosine 4x. It just stays the cosine 4x.
So that became 1/8 because you distributed it to each of them?
Because I was multiplying by 1/4, yes.
Okay.
Any like terms?
Wait, yeah.
It is a yes. Well, notice, okay, so read through the terms we have. We have 1/4. We have 1/2 cosine 2x. We have 1/8. And we have 1/8 cosine 4x. What can add?
The 1/4.
Yeah. 1/4 and 1/8 are just middle school fractions.
Oh.
Don't make it harder than what it is. 1/4 and 1/8 are just middle school fractions. Yeah. Okay. So what is 1/4 plus 1/8? I think I heard it over here. 3/8 altogether? Because 1/4 is 2/8, and 2/8 plus 1/8 is 3/8. Any other like terms? Okay. Well, and here's the deal. Look, are the cosines identical? No, one's a cosine 2x, one's a cosine 4x. For them to be like terms, the variable portion has to be identical. So I'm just going to say plus 1/2 cosine 2x plus 1/8 cosine 4x. That is one way to leave our answer, is like that. I'm going to say or. There's a second way to leave the answer. And I'm not saying that you have to do this. I'm just showing you options here. Some people would say, some math would say that it would be simpler to factor out a fraction. What would be the common denominator between these three coefficients? A denominator of 8, yes? Denominator of 8, don't ask. Okay, don't look at how many fingers I'm holding up because it doesn't make sense. So if everything has a common denominator of an 8, an equivalent simplification would be to factor out an 8. Factor out that common denominator of 8. Well, if it's 3/8 and I factor out 8, what remains? The numerator of 3. Plus, now you have to think on this one, it's 1/2, but if I factor out an 8, what is 1/2 in terms of 8s? 4/8. So if it's 4/8 and I factor out 8, what remains? 4 cosine 2x plus 1/8 cosine 4x. If I factor out 8, we're just left with cosine 4x. Okay, I went right to the edge of my notebook there. Well, good news for you guys that didn't want homework to work on tonight. I really thought, but
that's why I didn't want homework tonight. I wanted to do my
okay, well, so what I'm going to say, okay, we'll obviously finish those other two examples tomorrow. With any luck, maybe some work time. I don't know. I guess it comes down to it's been 2 years since I've actually taught this lesson normally because last year it was all weird with quarantine. So I thought it went quicker than this. Obviously, I was wrong. Have a good day, guys. Thank you, Shelby. You too.